Right, let's take a look at this problem. Add binary. Given a two binary strings A and B, return their sum as a binary string. So we just have to perform binary addition, and to do that we'll just go over from right to left in both strings at the same time. But if one of them is empty, we will just stop. So let's say that if you have like empty and one, yeah, so while I will have two pointers, pointer 1, pointer A, like yeah, pointer A is 0, I'm sorry, length of A, and pointer B is length of B minus 1 minus 1, and while PA is greater than or equal to 0 and PB is greater than or equal to 0, we just go over these, and or I can also perform maybe we can do one loop, but for now, just for the simplicity, I will make it 3 loops, so that it is easier to understand by looking at the code. So when until they are at the same, so if let's say that this is covering the case where the lengths are equal, so I will have remaining equal to 0, and here I'll just check if the sum to so if APA is equal to 1 and BPB is equal to 1, in that case we'll do something. So I'm just gonna do it like that, and we also have the case where we have that, right, 0 0, but in these cases I don't have remaining, so I will just have it as one case. So I'll have two case and one else statement, so I cover both of those with one else. If the sum is 1, I'll just go to else. If it is the sum is 0, then I'll just come to here, and so I'll be creating a new string because I cannot mutate the strings, and so this is the result, and I'll just make it result string will be that. And so here, if my remaining is equal to 1, then what I want to do is I have one remaining from the current, then I will put 1 to result. So result is equal to 1 plus 1 plus results, and remaining will stay the same. But here else, if the remaining is not that, so in that case we just want to result is equal to 0 plus results, and we want to change the remaining to 0. And here in this case, of course, we have similar case where, so if the remaining is 1, in this case we just make it 1, and we use it, so I'll just have to make it like that. And here the remaining is 1, so in this case, this remaining is 1, so I don't have to turn it to 0. So 1 second. So if you're 1 1, we have 1 remaining. Put it here. Remaining stays same. Else, I don't have the remaining. The remaining should be 1. Oops. The remaining should be then it should be, we have 0 remaining, and in that case remaining should be 1. Yeah. And here, if you have remaining and your result is 0, you just make it 1, and your remaining, you use your remaining, and so it becomes 0. And else, we don't have remaining, we don't even have to change it, so it stays like that. And in this case, again, we will just copy this and put it here. If you have remaining, then in those cases you will have 0, but have remaining 1, because your sum is 1 in the else case. Then you add 1 from remaining, you have 0, and you have remaining 1. And in this case, I don't even have to change the remaining because it was 1. So here, oops. So at this point, if the remaining is 0, you just have to have 1, and your remaining will be that. So I think we cover all the cases. So, and then if one of them is if one is, so at this point we will go through this, and we'll have we'll complete this while loop, and then whichever one is, so while PA is greater than or equal to 0, we want to do the separation again, but in that case we just want to copy from right and go left, but we have to take the remaining into consideration. So if the remaining is 1, then you have to pass that, and then like do accordingly, and do the operations accordingly. So if our current, if a PA is equal to 1, it can be equal to 1, and it can be, else it is 0. And in that case, if it is 1, and if remaining is equal to 1, then what we will do is that we will just sum those, and we will put 0 to the current location and results, and remaining will stay the same. We don't want to change it. And else, if the remaining is 0, we just want to put 1 there, and result, and remaining is 0, we don't change anything. And if the PA is 0, if the remaining is 1, we just want to put 1, but we use the remaining, so we make it 0. And else, if we don't have the remaining and the P is 0, we just make it like this. And I'll just copy this and paste it here. Make this PB, and this is B. Now it should be working as expected, and at the end of this I'll just return the result. So let's see if it works. I forgot to increment. Yeah, I'll get into infinite loop. So PA minus 1, PB minus 1. Oops. PA minus 1. PB minus 1. And it goes like that. So let's see. Okay, so my output is that because at the end of this, I should, yeah, see, I don't want to go in those cases, but theoretically I want to go in at this point, PA. I have to increase it by 1. Wait, why is this not working? Okay, let's take a look at this. Oh, I forgot to add that. So if remaining is equal to 1, results equal to 1. Let's try the other one. 1010 1011. Okay, so now it works. The complexity is here n plus m, which is like the length of A and length of B. So I'm just gonna make it time of n times m plus m, the length. And I'm not using any additional space, but I am storing it in the results. So it is still all spaces, again, the same because I'm summing them. So maybe, yeah, we might have, okay, the longest one, the length, let's see, if we sum them, this is like 1 1 1 1 1. No, I think it should be the max of these, max of n m. We just go over again here, max of n m, because we go at most that many times. So I think this should be the case, and this should be the complexity here in this case. And how can we, okay, how many minutes? 13 minutes. So how can we make this how can I put this in there? Yeah, I can put this in the same for while loop, but you're already continuing from that index, so you don't even have to do that because the complexity doesn't change. So it's just changing of readability. So I think this is more readable. So I'm just gonna leave it with this. So yeah.